So we left off yesterday with number 3. We did the first part. We did 3A, right? How fast is the top of the ladder moving down? We knew the top of the ladder was moving down because the bottom was being pulled out, right? Next question says, how fast is the area of the triangle formed by the wall, ground, and ladder changing when the bottom is 15 feet away from the wall? Okay? Same picture. They haven't really changed anything, so let me draw a new picture here. So here's the wall, here's the ground, diagonal is the ladder. Still hasn't changed, right? Still makes a 90-degree angle. They want to know how fast the area is changing. Okay. So, and then it says when the ladder is 15 feet from the wall. So if this is X, this is Y, and this is Z, which one is going to be 15 feet? X, Y, or Z? Mm-hmm. X is the ground, right? Okay. Okay, so we can use the other components. It's still the same ladder. So this is 25 feet. If that's 25 feet, that means this has to be 20 feet, just like we did yesterday, right? So we'll start listing this stuff. We know X is 15. We know Y is 20. We know Z is 25. Okay. What else? What do we? What's needed to find out? What's the step 2? What's the needed part? What part do we need to find out that we don't have already? What's the needed part? The part that I don't know that I need to find out to answer the question. So what about the area? So just the area? Okay, so how do we write that? I know it's going to be question mark, right? But how do we label that part in green that I have highlighted here? How do I label that? What label do I give it? That works. How fast is the area changing over time? That's what they want to know. Okay. Now, what is an equation that relates everything that we have with what we want to know? What's an equation that relates everything? Would we use Pythagorean theorem for this one? It's like I used the last one. The last one I used Pythagorean theorem, right? Would I use Pythagorean theorem for this question here? No. What would I use for this question? So let me ask this question. Why would I not use Pythagorean theorem for this question? Yes, side lengths, right? And I have all the side lengths. So that's not a question. It's not a question of the side lengths aren't changing. It's not saying these guys are changing at all. And I already know all of them. So why would I use Pythagorean, right? Which formula am I going to use instead? Go ahead. Pi r squared. So area equals pi r squared. That's area of what? A circle. Close. We're getting closer. I'm going to need area of a. Go ahead. There you go. Area of a triangle is 1/2 times base times the height. Or base times height divided by 2. Either one. That's the area of a triangle, right? You're right. We're going to use area. We're going to use those later. But those are for circles and for 3D objects. There's different ones. But this one here, we're just going to use area of a triangle. Okay. We have our equation. What should I do before I differentiate? Before I start finding derivatives, what should I do? Yeah. B and H don't make any sense to me right now because I didn't use B and H. I used X for the base and Y for the height. Because if I would have differentiated, I would have had B's and H's, and those wouldn't have made sense to me because if on my picture I don't have any B's and H's, right? We used X's and Y's. Okay. So I got to find derivative of this guy now. So dA over dt equals, how do I find derivative of this? What am I going to do to find derivative of this? Product rule, yeah. You could do like 1/2 times 1/2 as the coefficient. It's a little lag there, I don't know why. But 1/2, well, you could do it like that. Or you could say, you could put the 1/2 with the x, it doesn't matter. Whichever's easier for you. Okay? So if I leave it like that, we have the first times the derivative of the second plus the second times the derivative of the first. Okay? Plug in. dA dt, we don't know. I don't know dA dt because that is the question. 1/2 x is 15. What is dy dt? Mm-hmm. Yeah, that's what we did last question, right? -9/4. We didn't list that for this one because it was already listed for the last one. Y is 20. 1/2 dx dt. What is dx dt for this guy? 3, yeah. Mm-hmm. We said 3 last time, right? Okay. All right, so let's see. We're going to get negative, what is it, 15 times 9. Let's see if I can reduce any of these guys. No. I have 8 on the bottom. 15 times 9. See, 10 times 15 is 150. So 135? Negative 135? Plus, this guy I can reduce. That guy goes in there 10 times, so it becomes a 1. That is 30. Okay, now we have to add them together. Well, common denominator is going to be 8. So to have a common denominator of 8, I have to multiply 30 by 8, which is 240. When I do that, I get 105 over 8. Oops. Can't be reduced. There's nothing that goes into them besides one, both of them. So leave it like that. My question is, units. What units does this guy get? What units is this guy going to get? Yeah, feet squared because it's area, and it's a rate, so it's over time. There you go. Okay. All right. Okay, so now number 6 is a 3D shape. Number 6 is a 3D shape. Nothing about this question is different than anything. The only difference between this one and the ones we've been doing is this is a 3D shape. Is that going to change any of our steps? No, not one. We're still going to do list what you know. We're still going to do list what you don't know. We're still going to do find an equation that relates everything. Differentiate. Plug in, solve. Okay, so just because it's a 3D shape doesn't change anything. So the radius of a sphere, so now we have a sphere now, okay, is increasing at a constant rate of 2 meters per second. At the instant when the radius of the sphere is 5 meters, what is the rate of change of the volume? And then it says the volume of a sphere can be found using the equation V. Round your answer to 3 decimal places. So now they want us to actually change it to a decimal. Okay? So if they say round your answer to 3 decimal places, it usually means we can use our calculator. Otherwise, it wouldn't say that. Okay? So for 3D shapes, it's kind of hard to draw pictures, but you can, right? A sphere. Just think of a basketball, volleyball, right? The radius goes from the center to the edge. From the center to the edge. Right? We'll call that R. Since it's a radius, we'll call that R. All right. Step 1, what do we know? So what do we know for sure about this situation? What are things that we know? What are the things that we know? The radius. What is the radius? R is 5. Good. That is definitely something we know. What else do we know? There you go. The radius is increasing at 2 meters per second. So that's going to be written as dr dt. It's increasing, so it's positive too. I think that's all we know. Okay. What do we need to find out? What is the question asking? What is the rate of change of the volume? So the radius is getting bigger. The radius is getting bigger. So the volume is going to be getting bigger. Well, how fast? That's what it's asking. How fast? So how do we write the yellow part? How do we write the yellow part as a, how do we label that, I should say? There you go. That works for me. Okay. So the equation that relates R, dr dt, dv dt, they gave to us. It's actually volume right there. Volume. So this one we don't even have to find or guess or anything like that. It's given to us. Area of volume of a sphere is 4/3 times pi times r cubed. Okay. Next step, derive. Okay. dv over dt. Do I have to do product rule here? No, yeah, no. Pi is not a variable. The only variable I have here on the right side of the equal sign is r. 4/3 and pi, they're both constants. So I can just use the power rule. So I'm going to move the 3 in the front, multiply that times 4/3 pi, and r is going to lose a power. But don't forget about dr dt. Don't forget about that because it's with respect to time. So the 3's just cancel out to 1's. So I have dv dt equals 4 times pi times r squared times dr dt. Okay. Last step, plug in what I know. I don't know dv dt. I don't know that. So that's going to be my missing. 4 times pi. R, we said was 5. dr dt is 2. Okay. So 4 times 25 is 100, times 2 is 200. So it's going to be 200 pi. Personally, I'd prefer to leave it like that. But since they told us to round it, we got to round it. Okay. So I'm just going to use regular old calculator. Hold on. Thank you. So I'm going to use a regular old calculator. 200. Where's pi? Pi. It said go round 3 spaces. 628.319. 628.319. Okay. So it's approximately that. What? So now last step. What? Yeah. So it's volume. So it's going to be cubed, right? And we're talking about meters. So meters cubed, but it's also a rate. So what did they say? Seconds? Mm-hmm. There you go. Okay. Okay. So I want you to do number 7. Number 7 is a circle. It's a circle. It's 2D, 2D object. Okay? So I want you to try number 7 on your own. Okay, so area of a circle is increasing at a constant rate of 79 square centimeters per second. At the instant when the radius is 7 centimeters, what is the rate of change of the radius? So I highlighted it. The yellow is what I know. The green is what I need to know. Okay, so the yellow area of a circle is increasing at a rate of, so that's area is increasing. So dA over dt equals 79. At the instant when the radius is 7 centimeters, what I don't know is the rate of change of the radius. So that's dr dt. That's what I know. Okay, so I'm going to use area of a circle, pi r squared. So when I derive that, I get dA over dt equals 2 pi r dr dt. dA dt is 79 times 2 times pi times r, which is 7, times dr dt, which I don't know. $79 equals 14 pi times dr dt. So how do I get dr dt by itself? What do I got to do? Divide by 14 pi. dr dt equals 79 over 14 pi. Okay. So when I put it in my calculator to approximate it, 79 divided by 14 pi. 3 spaces, 1.796. So we say dr dt equals 1.796. How do we label that? How do we label dr dt? There you go, centimeters per second. It's not an area, it's just a measurement. So it doesn't get a squared or a cubed. It's not an area or volume, it's just a measurement. Okay. Okay, so number 8. Number 8 is cylinder now. Soda can. Okay. That's all a cylinder is. Cylinder, the height of a cylinder is decreasing at a constant rate of, so let me draw a cylinder real quick. Okay, so I'm going to highlight, underline stuff that we know about the cylinder. So the height of the cylinder is decreasing at a constant rate of 5 centimeters per second. Know that. The volume remains constant, a constant. Okay. At the instant when the radius is 5 centimeters, what is the rate of change of the radius? Okay. So the height, so let me label this for real quick. The radius is right here. The height is right there. The radius is from the center of the can to the edge. The height is the height of the can. Okay, so that's what they're talking about. The height of the cylinder is decreasing, at a constant rate of 5. So the height of the cylinder is decreasing. So that's dh dt. It's decreasing, so it's negative 5. Okay, next one. Volume remains a constant 162. V equals 162. It's not a rate of a volume, it's just the volume. Radius is 5 centimeters. What is dr dt? What is the rate that the radius is changing? That's what I know. Everything that relates V, R, and H is given. Okay. In this formula here, so for this guy, I'm gonna have to use product rule because R's and H's are variables. So again, you can do that, or you can do that. Doesn't matter. Pi is a constant. Pi is a not a is a coefficient. Okay, pi is a coefficient, so it can go with r squared. Okay. All right. So here we go. dv over dt equals the first times the derivative of the second, which is just dh dt, 1 dh dt. And then the second times the derivative of the first. So that would be 2 pi
r dr dt. Okay. All right, so dv dt we know. No, dv dt we don't know, right? Do we know dv dt? We do, right? I thought we did. It's remaining constant, right? Yeah. dv dt, it's remaining constant. That's why it said it's remaining constant. So what is dv dt going to be? 0. Should have listed that earlier, but oh well. Pi times r squared. R is 5. Times dh dt. Negative 5. Plus h. Do I have h? No, I don't have h. Let me move this down here so I give myself a little more room. I'm already trying to find dr dt, so I can't have another variable. So how do I find h? Mm-hmm. Yeah, because I know v and I know r, so I can plug it in to the volume and solve for h. I have enough information. It's kind of like what we did with Pythagorean theorem, where we didn't have the hypotenuse. And we said, well, how do we find the hypotenuse? We use the formula. It's the same thing. Okay. All right, so volume, I know the volume, 162. Pi times r squared, 5 squared, times h. So that's 162 equals 25 pi times h. Divide by 25 pi. I get 162 over 25 pi. Don't change that to a decimal. Why should I not change that to a decimal? It said round. Why should I not change that to a decimal? Yeah, because that's not my final answer, right? When they say round, they only said round your answer. They didn't say round anything else. So I'm just going to go plug that in over here. So h is 162 over 25 pi times 2 pi times r, which is 5, times dr dt. Over here, I get 25 pi times negative 5, which is negative 125 pi. Over here, the pi's will cancel out because all of these guys are over 1. Pi, pi. And then the 25 will be a 5, and this will be a 1. So we have 162 times 2, which is 3. 3 what? 324? Yeah, thank you. Over 5 times dr dt. Add 125 to both sides. Pi. Okay. Divide both sides by 324 over 5, which is the same thing as multiplying by the reciprocal. So 324 over 5. Five times 125 is 7 something. Let's see, 100, 500, 725? 625, thank you. 324. Now I can round. So I'm going to go to my calculator. 325 or 625. 625 pi divided by 324. .060. What label will that get? Centimeters per second. It's a radius. Okay. Okay, so the last couple are where we're going to include that step we've been not worrying about. This is where we're going to need another equation. You'll see why. Okay. Okay, so it's a circle. So underline, highlight. I want you to do step 1 and step 2. What do we know? What do we need to know? Okay, do that right now. I'll give you about a minute to do that. Read the question. What do we know? What do we need to know? Area of a circle is decreasing at a rate of 135 square feet per second. At the time when the area of the circle is 9 pi, what is the rate of change of circumference of the circle? This is when you know it's one of those questions where I'm going to have to use step 4. Because they give you a bunch of information on one thing, and then they ask you a question about another thing. They talk about area, right? Here's area. They give you this, they give you that, and then they say the question relates to something different. That's when you know you're going to need to do step 4, right? To do this one, they say, here's the area. Area of a circle is decreasing at a rate. Area of a circle is this. What is the circumference? Circumference and area are two different things. Area is how much stuff fits on the inside of that circle. What's circumference of a circle? Yeah, it's the perimeter of the circle. How long is it to go all the way around? So if I wanted to walk from here to here, how far would it be? It's perimeter of a circle. Okay? That's when you know you're going to have multiple equations. Okay? So let's use the equation that relates. The equation, we have two equations here. Area of a circle is pi r squared. What's circumference of a circle? Just 2 pi r. 2 times pi times r. Okay? This is the one we're going to need to answer the question, right? Because we need to find dc over dt, right? That's the one we're going to need to find. Okay? So I'm going to do that right now, but there's going to be a problem with that. I don't know dc dt. That's what I'm trying to find. I know 2, I know pi. I don't know dr dt either, right? So these are the two guys that I have no clue what they are. This guy and this guy. I have no clue what both either of these guys are. I need one of them to find the other. Well, what is a way I could do to figure out one of them? More importantly, more specifically, dr dt. So find the radius first. That would be important. Do I have enough info to find the radius? Because I know area, right? So I know area. So area is 9 pi. So if I go 9 pi equals pi r squared, right? I can divide by pi. What's radius going to be equal to? 3. Radius has to be positive. The rate could be negative, but radius always has to be positive. Okay, so I got radius. How do I find dr dt? Yeah, so treat this guy as your equation. Even though that guy's not going to give me my answer, treat this guy as your equation that I'm going to do. So I'm going to derive this guy right here. That'll tell me dr dt. Okay. So let's see, area. Pi r squared. So dA dt equals 2 pi r dr dt. Okay. dA dt I know, negative 135. 2 pi r I know, I just found that out, it's 3. I don't know dr dt. That's okay, I can solve for it. It's the only thing I don't know. So I get negative 135 equals 6 pi dr dt. Divide by 6 pi. Okay. That's dr dt. So let me add that to my list of stuff that I know. Now I can do it. All right. dc dt I don't know. times 2 times pi times dr dt. Okay. 2 pi cancels out with this to make 3. Because 2 goes into 6 3 times. Pi goes into pi once. So this becomes a 1. So dc over dt equals negative 135 over 3. And it says round your answer. So we're going to divide it. 135, negative 135. Oh, we don't need to. Negative 45. What units is that going to get? What units does circumference get? Yeah, so circumference is a length. So it doesn't get squared or cubed. It's just going to get, it's going to be, what is it, feet per second? Yeah. Circumference is a distance. It's a length. Okay. So that's the hardest type of these. When you're trying to solve for one, but you don't know enough, so you have to use another equation to figure out the stuff. Okay, that's the hardest part about these. That's the hardest type of question you'll see. Okay, so what I want you to do right now is I want you to do, let's see, cube, sphere. Do number 10. Don't do a cube because we haven't done a cube. It's the same thing, but I don't want that to trip you up. We've done a sphere, so do number, I'll give you a hint. This one you're going to need to use multiple equations, and in fact, they give you both equations. Okay? Okay, real quick. So I listed my stuff out. The question is surface area. They want to know where the rate of change of surface area. But I didn't have enough to get in there. I didn't have enough to calculate after I derived surface area. So I used volume, derived volume, plugged in what I knew, and then was able to get dr dt, 131 over 16 pi. And then my last step was to plug it in to surface area. So that becomes a 1, that becomes a 2. So I get 262 over 2, which is, oh, those 2's cancel out. 131. Area, yep. Is it negative? Negative 1, is it negative 131? Decreasing, yep, you're right. So negative. Surface area, it's area. So it's going to be feet squared, right? Feet squared per second. There you go. Okay, I'll post the notes, so if you didn't see it, it'll be on Google Classroom. I always post the notes, so if you miss something, it'll be on Google Classroom. Okay.